Good morning. My name is Mark Braithwaite, and I'm from Wolfram Research Europe. Today, I've got a very interesting presentation for you guys. I'm going to give you an insight into some of the technical services projects we've done within the company. So these are individuals or companies that have come to us with data, problems they need solutions to, stories, all sorts of things. And what I'll be doing is I'll be passing some information on to you guys, the bits I'm allowed to actually tell you, about what the project was, what our involvement was in it, and some of the interesting tales I may have to tell as a result. So, hence my point of it's a case study story. Just in case you're wondering, technical specialist is the worst job title ever. It explains nothing about yourself. I'm technical and I'm special. That could just mean I walk into doors for all you guys know. Who knows? Anyway, what it means is I get to play around with the tech, do some technical services projects, find out what we can do and present to you guys. So I get all the fun, basically. So, to start with, I'm obviously going to go with explaining a little bit about what AI can actually do when it comes to what we use it for in these technical services projects, to give you a bit of an idea of some of the capabilities that we actually do use. The first one, which I'm hoping will give you guys a bit of a giggle, will be simple computer vision. The idea that you can take a picture directly from your webcam, live in front of everybody, and try have it identify what it is seeing. Quite nice and simple. Thankfully, I've been given a bottle of water, which it identifies straight away. That's quite nice. How about my strange little mouse? Barbell, oxygen mask, ocarina? Thankfully, it's still classifying me as a Darth Vader. Please don't quote that. I am not Darth Vader. I'm not that evil. Image background, conference center. I'm quite happy with that one. That's quite good. Martial arts gym, I wish. If I could learn martial arts, what a person I would be. My favorite would be facial gender. Let's see what I am today. Am I male or female? What's it going to go for? It's gone for male. Woohoo! Some days it goes for female because it finds the long hair. It's quite funny, actually. There we go. See? You saw female briefly. And facial age. Bit of a quick one of, is it going to insult me today or be nice? I've got good light, so I'm hopeful. Come on. Come on. Still on male. 30, 33. I'm 25. Come on. Guess it's the beard. Can't blame it. Makes me look older. Anyway. That's just one of various examples that I have, including character recognizing, so drawing a 7, and you can see how the system changes to try to recognize that 7. Or another one, maybe a 4, which really doesn't get until suddenly you put the middle bit in. And even then it's not quite sure. Maybe it's a 6 that's not been finished, maybe it's an 8. Who knows? It's my handwriting, you never know. What can I say? Or the other one I was playing around with a second ago to check the internet. Come on, don't let me down now. Please. Would you please? No? Okay. We'll go for simplifying maps. Or impute missing data. There we go, simplifying maps. So using a neural net model to take an aerial photograph and convert it into a Google Maps style image. As you can see, I've gone for Las Vegas, Nevada, because why not? And it actually has come up with a surprisingly accurate representation of that particular geographical area. In this case, I did this just before the presentation, because I knew the internet might be a bit patchy, so I apologize. But these are just some of the various use cases. As you can see, I've actually got quite a few here. So the reason being is, if you guys would like, if you come over to the stand afterwards and grab my email, I'll send you a copy of the presentation. You can do some of the examples yourself and actually keep a copy of it. Because there's other ones like anomaly detection, etc. And some of them are quite fun. But as I've only got half an hour, I'm going to have to jump straight into the projects. So these are some of the things that we've actually had to do. And the reason I say it in such a way is because the first one is slightly strange. An anti-cat sprinkler system. Has anyone tried doing this before? Probably not, I'll admit that. we had a particular individual coming in who's saying, right, I have a sprinkler that goes off every time it detects motion, and I'm fed up of having to dry off my kids when they come into the house. So that didn't go down too well. So we went for a sprinkler system which can be connected up to a Raspberry Pi with a camera. Bit of image recognition. You can detect when a cat comes into the garden. It will set off the sprinklers, cat gets soaked. Cat disappears, no problem, no one's been harmed. However, it ended up having the same problem of it still soaked the kids. And it all came down to our very interesting lesson of it's not always about getting the correct answer. So that was an interesting one. It would accurately identify any breed of cat. It wouldn't even just say domestic cat like it does in this case. It would tell you what breed of cat it was, so you could actually tell which neighbour's cat was the one that was annoying you, or wouldn't give up. However, if it saw his children, because it didn't say cat, it wasn't quite sure what to do. So in some cases it just set the sprinkler system off anyway, just in case, because it was designed to, if in doubt, set it off. So again, didn't want to have to dry off the kids every day when they come home from school. That's not quite something you expect to have to do, I'll be honest with you. So our lesson from that silly little project, which was actually very useful in this case, was that sometimes it's the checking the false negatives that is the important bit. So checking out what happens when the system incorrectly classifies something it sees. Next one, bit of a marketing example, quite a bit of a shift, I'd say, from sprinkling cats to people calling people. This one's actually quite important because it's not cold calling. We're not talking the poor call center person who has to sit there and ring up thousands of people in a day, otherwise they don't get paid or whatever. I don't know exactly how it works. I'm over-exaggerating there, I hope. This is a particular group who have permission to contact various people who've given in their details, and they're all about making connections between people who sell products and people who might want, essentially. I think they're called channel partners or something like that. Someone can correct me later, please do. I could actually do with that information for this presentation, as you can see. But the idea is that you're going to have a list of 4 or 5 people you wish to ring up that may wish to sell a product, and you need to figure out which one's going to accept that call and be willing to sell that particular product for you. In this case, the client specifically wanted to find out how likely they were to accept based on how the call was going. Because sometimes it's the little things that people say that actually mean, sorry, no, we're not interested. But they won't say that, because funny enough, if you're in the UK, we're not very good at actually saying no. We'll give you some polite, fuzzy answer that means that we're not quite interested, but we're not willing to tell you because we don't want to be impolite. So we're trying to kind of detect that, which is quite difficult, actually. So we're trying to come up with a predictive model that would take in all the data you would get during the call and could flag up to them saying, no, this person's not actually interested. You might as well just let them be and have a good day. We learned another valuable lesson in this one, in that, firstly, human intuition is not always correct. When you think about it, it's the human that's building the machine learning or AI model and the system that you're working with. So if the idea that person has is not quite perfect, in this case, we believed there was going to be a signal in the data that someone would say a certain catchphrase or something like, yeah, I'll get back to you, or something like that, and we'd be able to detect it. Sadly, that wasn't in the historical data. We had this huge amount of data, and we could get absolutely no signal whatsoever from it. There was no accuracy whatsoever that was useful in terms of predicting these calls and whether or not they would go well, because the data was all over the place, which was understandable. But as we realized, whether or not John Smith is having a good day is not actually any historical data. If that person's having a bad day, they're probably just going to say no because they don't want to sit for ages on the phone, and they've got something they consider more important to be doing at that time. So sometimes the signals that you need aren't always in that large volume of data. So more is not always means better. Filming locations turn out to be quite complex. You need licenses and permissions, and if it's a public place, you've got to make sure that members of the public don't walk across your shots. Turns out this is also very complex. Simple idea. Director's walking around, sees a lovely place he likes, and believes, yes, I want to use that for my next film. Perfect. Takes a picture to remind himself for later. Then the poor guy has to ring up various places to find out, is there anywhere suitable? Is there anywhere that already has licensing? Is it going to be easy to close off that particular road for a day? We wanted to make that a little bit easier. Apparently there's companies out there who track these kind of things for you. So they'll find out what sites already have licenses for filming and stuff like that. We just wanted to make it easy. Simple interface, put in your picture, it will tell you where you can look that's similar, that already has this licensing. So for example, we had a picture of Tower Bridge. Quick check on how far you were willing to go. You can see we've gone not very far in this case. 100 miles is not actually that far, it turns out, when you're looking for filming locations. Some lovely results, giving you roundabout locations on what could be useful. And then some pictures for the various north, south, east and west. As far as we were concerned, this was perfect. This was exactly what the customer asked for. And they genuinely did seem very, very, very happy with it. But there's always a but in these stories. That's the whole point of them. It turns out we never asked the right question. Yes, this is a brilliant and cool little tool that we are now probably going to put on the internet just for amusement because there's nothing important on there. It's just using Google Maps API. However, as I said, it wasn't the right question. We didn't ask what the person was attempting to achieve. They just said they wanted to find locations similar to this a picture. What we discovered is that's not the same as finding a filming location. As I said at the beginning, you need licensing and road closures and things like that. It gets really complicated. So, cool little tool, nice little story, not the right project. Next one, wind power maintenance. This one, quite nice, huge wind farm offshore, loads of data, every second, far too much to even think about, loads of historical data. Just want to predict, is that wind farm, is that particular turbine going to fail on Monday? If so, I'll order the parts in now. Because it turns out you can't store turbine blades very easily. They are absolutely huge, they cost loads to manufacture and even more, in fact, to store. Don't do it. Some custom parts as well for these turbines, really expensive. You don't want to have to store them because they'll depreciate over time, wearing and whatnot. So the easy idea, predict ahead, send an engineer out, fix it before it becomes a problem. This one was all about the dataset size and the model. We initially started with a small set of data, historical, and our initial predictive model was amazing. It came up with, I think it was a 92% accuracy, which from not really doing anything is impressive. We were really pleased with ourselves. We're like, oh, this is in the bag, great, easy project, done in a few days, we'll sell it, it's great. No. Attached it to the live data and it was wrong. Because the historical data didn't account for changes in weather that are now present that weren't several years ago. Couldn't predict strange happenings like sudden gales that had come in or beasts from the east by any chance, that kind of thing. You don't really have historical data on that. So it was great, but the model couldn't adapt and it struggled. So we had to be really careful. We changed the model, found some more appropriate data from other sources as well to implement what we already had, and vastly improved that, and eventually it's now in implementation. Very happy with it. Slightly more gruesome. If you've just had your breakfast, I apologize. You may look away now, or close your eyes. I wouldn't blame you, and I wouldn't think you're asleep, so don't worry about it. Identifying polyps in the insides of a person apparently is quite difficult, and normally involves a very interesting procedure where you have something not comfortable. So, if we can avoid that, we will. Little capsule with a camera in it, swallow it, techniques recordings all the way down, sends them to a doctor. No discomfort, brilliant, no change to your day. However, several hours of footage, which some poor guy has got to sit there and look through. That's grim. I don't know about you guys. So, if we could extract certain images out of that picture of this might be interesting to look at, please check that. You can cut those several hours of footage down to, 15 minutes? of just, say, 100, 200 images and their surrounding bits of video to double check, saying, is this of interest? Suddenly that expert you're having to pay goodness knows how much money to be there all day can go from seeing, I don't know, 4 or 5 patients' bit of data a day into 10 or 20. Already much more impressive. Went well to start with. Key thing here was that whilst we did really well and came up with an amazing interface, we had to point out it's not a replacement for the doctor. It needs to be supervised and it needs to be looked after. This is an important topic. Don't ruin it. So we ended up with a lively feedback loop as well, where the doctor could say, no, sorry, that's actually fine. You've misclassified it. It's fine. Leave it alone. Data feeds back into the system and improves. So it needs the doctor. You mustn't forget that in certain circumstances, yes, it's great to use AI to help, but it doesn't replace humans all the time. In most cases at the moment, it actually can't directly replace a human, really. You still need their help at the beginning. Another NHS example. Slips, trips and falls. This was an interesting one. We had a particular ward. There was plenty of accidents, but for whatever reason, and no matter how many staff they put on the ward, it didn't seem to make a difference. Gave us this large set of data and said, can you find out what's causing it? Initially, we were very pleased with ourselves. We came back with an answer straight away. And then we sat there laughing for an hour. And they were like, well, what's so funny? You're on the phone call to us and you're telling us that the solution is really silly. What is it? And we said, make all your patients vomit. And they were like, what? So, yeah, apparently if people are vomiting, they don't get in accidents. And that's when everyone burst out laughing, because we realized if you're vomiting, you're not going to leave bed, are you? Otherwise you're going to fall over yourself all the time. However, you can't make a load of patients vomit. You're not allowed to do that. It's not sensible. So whilst it was initially amusing and we got some very strong signals, we did actually have to change the project into a very agile setup of saying, look, we've got this signal, is that useful? How we got this signal now, is that one useful? And constantly checking what we were doing. In the end, we found out it wasn't exactly the number of people on the ward, it was the number of highly trained people on the ward that made a difference. You could have 20 trained nurses on that ward following behind every single person, every single step they made, and it wouldn't actually help in some cases, because the nurse might not notice when the fall is going to be happening. They might get distracted, or they might not be aware of certain situations. But you have an amazing doctor, who's spent goodness knows how long training and has seen it all. He's going to be on the ball. He might be a bit tired, but he's more likely to catch all these accidents that are going to happen. And we found that to be true. And apparently it's been checked, and they are now having more success on that ward, just by having one senior doctor around at all times. Who knew? Less staff, more training. Another one. This one's about ground treatment works. There may be one or two in this audience I've mentioned this to previously. Large site, oil spill all over the place, horrible to clean up. Apparently it costs a lot as well. £200 for every square metre of dirt doesn't sound like much. But when you think about the fact the whole site was going to cost several million to actually clean because they couldn't tell what was dirty, they had to just dig up the whole field and go again. That's horrible. We promised them we could save them money, and we did. We were able to accurately predict where the oil had spread from and to be able to give them an accurate model of exactly what was going on in that field. They could then see what dirt was contaminated, and from there just dig up what was needed, saving hundreds of thousands of pounds. However, that worked great for the data analysts and the other people who were doing the predictions, but you give that to some poor guy in a digger and he has no idea what he's looking at. So we did absolutely brilliant in one aspect, but then we had to change our visualization to actually help the guy realize that I need to go 200 meters from that fence and dig up this square meter here. Because telling him he needs to go to longitude and latitude this is not helpful for some poor guy in a digger. He needs to get some kind of GPS thing and make sure the signal's correct, and no, not a good idea. Just stick to simple directions like that. Works really well. It was also we needed access to other computations in this case. Just shoving machine learning at it didn't actually help too much at the beginning. we actually had to make sure that we changed the different computations we did to create those interesting visualizations and the instructions for the diggers and what digging patterns they needed and all sorts of other things. You can see we're a big fan of the NHS, third project. This one, I'm going to say right now, before I continue, was a failure. And I'm actually quite proud to say that, once you realise why. We thought tracking patients through the NHS, perfectly easy. You know, we'll have a lovely flow diagram, we can show you which bits are slow, what the problems are. It'd be really easy. However, we weren't allowed to identify any patient whatsoever. We shouldn't be able to single anybody out. That's just sensible. You don't want to give away anybody's data. Which is where the problem came in. As soon as we could identify where a patient was at a particular time, we knew who the patient was. We needed a unique identifier to track them. And as soon as we gave a person a unique identifier, you've identified them. There's the problem. Which meant that really we didn't have any data. Some poor data scientist in their basement, probably sat in some office or basement or whatever, had gone through their data set, anonymized as much as possible, and gave us a set of numbers, which meant nothing to us. And they couldn't tell us what they meant either, because we could identify the patients. So yeah, it was a spectacular failure. And we're actually happy about that, because it identifies the point of, yes, sometimes that is going to happen. Security and GDPR and stuff are going to get in the way, and that's actually a good thing. You know, they're there for a reason. So it kept everyone safe. So yeah, no data, no answer. Pretty obvious, really, but still something I thought I'd point out. If you're into finance, testing trade models. In this case, we didn't do the AI creation ourselves. I'll admit that now. We were just told we need to do mass training of an AI and testing, and we need to check it works on historical data and be able to test at will. You know, we get given a new model by our other, our AI guys. We get given it, we want to test it on our data really easily. Simple interface to use, shouldn't take too long. Nice and easy. Here we have our AI trainer. You give it a model, you give it a data set, you give it some options, you set it off, and it gives you some reports. Like so. Really happy. Really good. Simple and easy. However, we could prove with the testing that those AI models were amazing. We were talking 98, 99%, which we were really pleased about, and they were as well. However, the validation we were using wasn't relevant to the finance examples. So we were testing on this historical trading data, and it could accurately predict what had happened 10 years ago. What we realized afterwards was that doesn't necessarily mean you can predict what's going to happen tomorrow. Those things are not actually always related. So yes, we got great accuracy on the testing, but when they came to implement them on dummy data, they all fell over. They were useless. But you asked them what happened 10 years ago, and should we have done this trade on that day? Yes, it would give you the exact perfect answer, because it knew the answer, really. So we had to should have checked what the validation should have been, rather than just saying, yes, all our tests come back positive, there you go, it's perfect. We actually should have checked what the validation should have been, and then had a separate test for that future data, that dummy data they created. Again, it's about asking the right questions in a way. One of the ones my favorite project in this case, was tinned food. I had never thought so much about tinned food in my life, apart from when we took on this project. We had a company that was simply putting meat in a tin and wanted to make sure it would come back out again. So simple. Except for the phone call made me giggle, because the guy was going, it tried explaining it by saying, you know when you empty the tin and it goes splop? And we all giggled, and he couldn't figure out why. And we were just like, well, you mean when the meat just comes out the tin? And he's like, no, it makes that specific sound. And we're just like, okay, we'll go with it. Anyway, it turns out how easy meat comes out of a tin is actually related to the preservatives around it and what's in the meat. The fattier the meat, the actually easier it comes out, and so on and so forth. As you can see, I've got a bit of a sample data set from the anonymized data they gave us. And it's all about how the combinations of the different items make the meat come out easier or not so easy. They called it the drop value, or the sloppy factor. I'm not too keen on that last one, but it sounds amusing. And it was really nice and simple. We didn't actually use machine learning to start with. We thought, statistic modeling, perfectly fine, absolutely fine. But we were a bit worried that there wasn't enough data. I'll be honest with you. We got, I think it was 34 bits of data like that. They're not complex, there's hardly anything there. And we thought, that's not going to be useful. That's going to be useless. Again, we were wrong. Because the problem is that simple, and there's only 5, out of all those values, there's only 3 that actually matter, it turns out. The other ones don't seem to make a difference. Probably to do with something in the tin, I don't know. But because there was only 3 things to focus on, 34 data points was enough. And it gave us a very strong signal. And now they're very happy with the slopping sound that they make when the tin meat falls on the plate. And apparently it's incredibly reliable. And they've never had any complaints. I'm not sure how they would get complaints about how easy a meat comes out of a tin, but hey, who do I know? I don't manufacture meat, do I? So a bit of a summary about the various things we've learned, and I hope I've entertained you guys for a little bit as well. Primarily, it's about asking the right question. Sometimes customers will come to you and they will have no idea exactly what they're looking for. That following conversation is a conversation. You ask questions, you check information. What validation should we actually be using is quite a key one. Do we just need all these tests here to come back positive? Or do we need to make sure that your sprinklers don't soak your children? That kind of thing. Try not to replace humans with AI, simply for the fact that the human was the expert. They know what was happening. You should have them double check that the AI is doing the job properly before you let it loose on all your data. Too much data can be a problem. Too little data can actually have a solution. So it's finding the right balance. It's actually kind of like a juggling act, actually. Not that I can juggle. Please don't ever ask me to do that. Don't always trust your intuition. Sometimes you're correct, or sometimes you're overzealous. It can happen. You can be working with these machine learning algorithms for years and understand them inside out. Doesn't mean that you're going to get it right every time. Don't underestimate the power of a simple visualization. I have a brilliant quote for this one. My manager went to visit one of our clients and got put right on the spot and said, "Are you telling me we've just spent X amount of money going from 2D to 3D?" And of course he was sat there going, oh God, how do I justify this? I don't know what I'm doing. They're going to think we're an idiot. And he turned around and goes, and someone else on the board says yes. And the manager goes, perfect. What? You're happy because we've just gone to 3D. Whatever. Up to you. Visualizations are important. And lastly but not least, agile methodology. Keep that conversation going. Don't just assume because you've got that initial set of criteria to meet that that's going to be the end of it. You do need to actually go back to them and check everything is fine. Is this actually what you wanted? We've had so many projects that have come in the door, had a nice straight path, knowing exactly what they want, and then 2 days later we're somewhere over there because they've come up with a new idea. They now suddenly know exactly what they're looking for. So yeah, that's been my little presentation. Quick point on we're Wolfram. We do technical services. Come see us over at the stand. Not going to bore you. Otherwise, any questions?